This section is all about performance optimization. I will introduce you to three-tier architecture, and I will show you techniques that you can apply in each tier to improve the performance of your applications. Now, let's get started. Okay, before we get into specific areas, I just want to point out a few things about performance optimization. First and foremost, my favorite quote is premature optimization is the root of all evils. I've seen developers messing up with the code and making it really ugly and unmaintainable, and they argue that this is for performance optimization. And in most cases, most of these people have not profiled the application and have no clue of performance bottlenecks. So don't sacrifice the maintainability of your code to performance optimization. Optimize only when you need to. Otherwise, you increase the development and maintenance cost without gaining anything. So one more time, I want you to remember this for the rest of your life, even if you're going to live forever. Premature optimization is the root of what? All evils. Okay, so you profile your application and you observe some performance problems in some areas. How can you solve them? Well, performance optimization is a very broad area and there's no magic fix for it. As a metaphor, think of infections. We don't have a magic pill that treats all infections in the world. We have different types of antibiotics, and each type can treat certain kinds of infections. Performance optimization in software is similar. You could have performance problems for a number of reasons, and unfortunately, I can't point out all the possible reasons out there. But I'm going to share with you a few key areas based on my experience. And this is not a complete list by any means. Now, in regards to web applications, most web applications follow a three-tier architecture. What is a tier? It's where your code runs. So we have data tier, which is where our database and queries reside. We have application or middle tier, which is where we have a web server hosting our application. And we have client tier, which is the client's computer, and here we have the front end of our application running in a browser. Generally speaking, most of the performance bottlenecks are in the data tier. So optimizing performance at this level will have the most gain. And as we move towards the client tier, our optimizations will have less observable result. Note the word observable. This is the key here that a lot of developers don't take into account. They spend a lot of time on various kinds of optimizations, and they feel proud that they have reduced the execution time of some activity from 50 milliseconds to 20 milliseconds, even under load. Yes, in theory, there is 250% improvement here. But is this really observable to the end user? Does this really value the business? Probably not. In contrast, optimizing your database and its queries can reduce the response time of your application from 5 seconds to half a second. Is this observable? Absolutely. So just to clarify, I'm not saying we should not spend any time optimizing the application or client tiers. I'm saying optimizing performance problems in data tier will have the most gain compared to optimizations in application or client tiers. Here's a real-world example. A while ago, I wrote an article on my blog showing a few tips for C# developers to write cleaner code, and in that article, I explained that by convention, we do the validation in our methods first. So it's cleaner to have these if statements on the top to validate the arguments and throw an exception. Then in the comment section, someone argued that no, we should reverse these if-else blocks for optimization reasons, and he tried to explain how CLR works, blah, blah, blah. Now, honestly, I don't know whether his explanations were technically right or wrong, but let's assume he was right. First of all, this is a perfect example of premature optimization, because his argument was not based on profiling the application's performance. It was purely based on theory. Plus, how much performance do you think we would gain by swapping these if and else blocks? So before teaching you a few techniques to optimize the performance of your applications, here are a few rules of thumb I want you to accept. First, do not sacrifice the maintainability of your code for premature optimization. Second, be realistic and think like an engineer, not a computer. And third, be pragmatic and ensure that your efforts in performance optimization have observable results and give value to the users and the business. If not, you're wasting your time and your employer's money. Okay, from the next lecture throughout the rest of this section, I'm going to touch on various elements in each of these tiers, starting from the data tier. Okay, so data tier. Performance problems in this tier are often because of database schema and/or queries. In terms of the database schema, make sure that every table in your database has a primary key and there are relationships between these tables. You should also use indexes on columns that you use for filtering records in your queries. Now you may think this is just stupid, but believe it or not, I've seen databases without primary keys and relationships. And this was actually only a few months ago, not 15 years ago. Now, in terms of our application, because we're using Entity Framework code first, our migrations automatically add the primary key and indexes in our tables. So we don't have to worry about it for the most part. And this advice applies if you're working with a legacy database. So your first point in optimization should be to fix these issues in your database schema. Another schema-related issue I've seen in my career is the implementation of a pattern called EAV, which stands for Entity Attribute Value. So instead of having concrete tables like movies, customers, rentals, our database has only a handful of tables called entities, attributes, and values, and potentially a few other supporting tables. People who like this kind of schema argue that with this, no matter how many classes we have in the application's domain model, we don't have to change the database schema, because everything can be modeled in a generic way using entities, attributes, and values. While this argument is technically correct, there is a huge cost with this approach. First of all, you cannot use any object relational mappers like Entity Framework, and you have to write all your queries by hand. And these queries can easily grow to several hundreds or even thousands of lines. Now, on top of all these ugly, super ugly queries, you'll have huge performance problems. Some queries may take easily half a minute to run. So please, please, please stay away from this pattern. Just because someone came up with a pattern and gave it a name doesn't mean you should use it. So, first you get your database schema right, next comes your queries. How you write a query can have a significant impact on its performance. In our Vidle application, we don't write queries by hand, at least we haven't so far. So all queries are generated by Entity Framework. And in a lot of cases, these queries are fine. But in certain situations, if you look at the query that Entity Framework generates behind the scene, you're not going to sleep at night. It's going to be extremely complex. We'll get to this later in this section. So it's good to keep an eye on queries that Entity Framework runs on your database. If these queries are too complex, it's better to create a stored procedure and write an optimized query to get the same result. And there's absolutely nothing wrong about this. Every tool has strengths and weaknesses. Entity Framework is great in the sense that it saves us from writing all these queries and mapping the results back and forth to our domain objects, but it fails in complex queries. That's when we use stored procedures for optimization. Also, in SQL Server, we have this feature called Execution Plan, which shows you how SQL Server executes your query. Now, this really belongs to a SQL Server course, not here, but I'm just giving you direction. So by using this execution plan, you can see what parts of your query have the biggest cost, and then you can optimize the query by rewriting it. Or you may also want to add additional indexes in your database. Now, what if you have done everything you could do to optimize your queries and they're still slow? Then you may want to consider creating a separate database for your queries. There are architectural patterns like CQRS or command query responsibility segregation that guide you in that direction. So because we read data more often than we modify it, we can create a separate database optimized for reading data. In that database, we pre-join some of our tables to speed up the queries, because joining tables is one of the areas that impacts the performance of a query. But just remember, this approach comes with the cost of maintaining two databases in sync. Otherwise, you're going to get a lot of calls from end users every minute telling you that they have added a new record, but it's not showing up. So unless you have got the right skills and the tools in your team, I would advise you not to go down that path. Another approach is to use caching, as we call it here in Australia, or caching, as is pronounced in the United States. So with caching, we run a slow query and then store the results in the memory. The subsequent requests will be served from this cache in the memory. We'll look at caching later in this section. All right, now I want to introduce you to a super awesome tool for getting real-time diagnostics and insights into your application. It's called Glimpse. So open up Package Manager console and install package glimpse.mvc5. And one more time, but this time glimpse.ef or Entity Framework 6. Okay, now run the application and navigate to glimpse.axd. So Glimpse adds this endpoint in your application, and here you can turn it on or off. This dashboard is only accessible locally for security reasons. So if you want to use Glimpse on an application that is deployed to production, you need to do additional steps, and you can read about it in the documentation of Glimpse. Now let's turn this on. So basically, Glimpse puts a cookie on your machine, and this cookie is sent back and forth with each request. On the server, Glimpse has a module that intercepts every request. If it finds this cookie, it will render diagnostics information for you. Let's have a look. So I'm going to navigate to list of customers. Okay, look, we get this little bar on the bottom of the screen. Here we have 3 tabs: HTTP, host, and AJAX. And if you hover over any of these tabs, you see more details. So this request took almost 700 milliseconds to execute. In the host tab, we can see what methods have been called to handle this request. So it was the index action or the index method of customer's controller. Now let's click on this G icon here. There is tons of data here in various tabs, and you really need to play with them yourself or read the documentation. But briefly, you can look at the items in the cache, you can look at the configuration settings used on the server, you can look at the HTTP request, MVC routes, and so on. Now on this page, we're using AJAX to populate the list of customers. It's our data table plugin that is querying our API to get the list of customers, right? So let's go to the AJAX tab. As you see, we have an AJAX request that took 7 milliseconds to execute. Let's inspect this request. Now, if you navigate to any of these tabs here, you see data related to this AJAX request. So we go to SQL tab. You see we have had 1 connection to the database, 1 query, and the total execution time of this query was 3 milliseconds. And if you scroll down, you can see the actual query that Entity Framework executed on our database. Now let me show you something. Don't type, just watch what I'm doing. In the customer class, I'm going to make this membership type navigation property virtual. This is one of those bad practices that many tutorials, including Microsoft tutorials, teach you. With this, you get lazy loading, which is the opposite of eager loading. So instead of loading a bunch of objects together, objects are loaded only if our code touches one or more of the navigation properties of an object. Why is this bad? Because in web applications, you should know ahead of time what data you're going to return to the client. With lazy loading, you will have multiple round trips to the database, and this will have a significant impact on the performance of your application. So to demonstrate this, I'm going to go to the customer's controller. And in the index action, I'm going to get the list of customers here. And then put them in the view. This is just for demonstration, okay? So here I'm not using the include method, which is for eager loading. Now let's go to this view. I'm going to iterate over these customers and render them and their membership type in a bunch of list items. So for each var customer in model, render customer.name and customer.membership-type.name. Now build. Back to the browser. Refresh. Now in the SQL tab of Glimpse, you see we have 3 connections and 3 queries, which used to be 1. Let's take a look at the actual query. So here's our first query, which is basically selecting multiple columns from the customers table. Then we have 2 more queries to get the membership type for each customer. We didn't have these 2 queries in the past. So what's happening here? Well, in our controller, when this line is executed, Entity Framework queries the database to get the list of customers. But their membership type is not loaded. It's not eager loaded. But here in the view, when we're iterating over each customer, when we touch the membership type property, Entity Framework is going to query the database again to get the membership type for that customer. So it will open a new connection, execute the query, close the connection, and the same story repeats for each customer in the list. So if we have n customers in the database, we'll have one query to get the list of customers and n queries to get the membership type for each customer. Now, more accurately, this is the worst case scenario. So in reality, it could be less than n. But that aside, this is what we call n+1 issue. And that's one of the questions that sometimes comes up in job interviews. So the bottom line is you should avoid lazy loading in web applications at all times. Now back in the browser, with Glimpse, you can easily keep an eye on the queries running on your database by Entity Framework. So if you find a slow page on your website, first open up Glimpse, see what's happening under the hood. What queries are being run on the database? How many queries do we have? What is the execution time of these queries? If you find an Entity Framework query that shows to be slow, then you can optimize by creating a store procedure and calling it via your DB context. Explanation of this is really beyond the scope of ASP.NET MVC course, and if you want to learn it, I would suggest to look at my Entity Framework course on Udemy. So assuming that our database schema and our queries are in the right shape and form, we're going to transition to the application or middle tier. There are a number of techniques we can use to optimize this tier. One that gives us the most gain is output caching. So here in index.cs.html, which is our home page, I'm going to add the current date time in this heading. datetime.now.toString. This is just for demonstration. So watch what I'm doing. Save. Now I go back to the browser. So here's the current date time. And if I refresh, you see the second changes. Okay? Now imagine behind this page, we're going to have a costly query and our performance tests are showing that this is one of the slow pages in our application. Now, assuming that the data behind this page does not change that often, we can cache the output of this page, which is the rendered HTML. The first time someone visits this page, we'll query the database to get the data. ASP.NET MVC Framework will render the page and then store the rendered HTML in the cache. Next time someone visits this page, MVC Framework will serve this page from the cache, so the query will not be executed again. Now to enable caching, here in Home Controller, I'm going to decorate this index action with output cache attribute. Output cache. So similar to the authorize attribute that you saw earlier, this is what we call an action filter. When we apply this to an action, it will be executed by MVC Framework before and or after the action, depending on how it's implemented. Or we can apply this to the controller, and this way it will be applied to all actions in that controller. Now here we can set a duration. Let's say 50 seconds. So I'm going to build, back to the browser, refresh. Okay, look at the time now. This page is now rendered and stored in the cache. But if I refresh again, the time doesn't change because this page is coming from the cache. Now we can cache the data on the server or on the client. If this view is specific to a given user, we put it on the client. Otherwise, we put it on the server. So here we can set the location property, which is an enumeration. Let's say output cache location.server. Another property that you might find useful at times is vary by param. Vary by param. So if this action takes one or more parameters and the output changes based on the value of these parameters, we can cache each output separately. So let's say in this action, we have a parameter called genre. I can add that here. So for every genre, we'll have a different version of this page in the cache. Or if we have multiple parameters, we can use an asterisk, which means for any combinations of these parameters, we'll have a different version in the cache. Now, as I said before, premature optimization is the root of all evils. So do not assume that a given page is going to be heavy and apply output cache here ahead of time. you're just going to shoot yourself in the foot. Do this only when your performance tests are proving that this page is slow, and you will benefit from caching it. The downside of caching is that you may end up displaying stale data to the users. So for example, if we cache the list of customers and our staff member adds a new customer, they're not going to see it. And this is a terrible experience from the user's point of view. They don't care about our performance optimizations. They just can't stand an application that doesn't work reliably. Now, sometimes to prevent stale data from being displayed to the user, you may want to deliberately disable caching. Because different browsers have different caching policies, and at times they may cache the results of some of the requests to our application. If you're getting calls from the users telling you that the data is not updated, you need to ensure that caching is disabled on the corresponding actions. To disable caching, we use output cache attribute again, but we set the duration to 0. We don't need location. We set vary by param to an asterisk, which means for any parameters. And finally, we set no store to true. This will disable caching on that action. So this is output cache, which is for caching the rendered HTML. But sometimes we want to cache data, and that's what I'm going to talk about next. Sometimes we may want to cache a piece of data, not HTML. We may want to work with this data across different actions or controllers. For example, in one of the projects I worked on a while ago, we had the list of roles that were used in quite a few different places. And this list didn't change that often. Perhaps it changed once or twice a year. So one of the developers in the team decided to put these roles in a cache. Now, this is another example of premature optimization, because as far as I know, he didn't do performance profiling before doing this optimization. So he just thought, because we use it in a few different places, it's better to cache it. Now, the end result was unnecessary complexity that ended up being a smell in our code base. And as we wrote more code, it just got worse. Of course, developers like that never accept this and take responsibility for their mistakes. And if you're working with people like that, my advice is to stay away from dogmatic arguments. Now, that aside, if you do your performance profiling and conclude that a piece of data is better to be stored in the cache for a limited period of time, here's how you do it. So in the index action of customers controller, let's imagine we want to cache the list of genres. So the first time someone hits this endpoint, we'll get the genres from the database and then store it in the cache. In all subsequent requests, we'll get the data from the cache. So if memory cache, this class is defined in a different assembly, so you need to add a reference to that. With ReSharper, it's pretty easy. Alt and Enter, reference system.runtime.caching. So if you're not using ReSharper, you need to manually add a reference to this assembly. This class has a static property called default, which is like a dictionary. So we can use an indexer here. So every item we store in a cache, we use a key to access it. Let's call this genres. So if this is null, we should get it from the database. Memory cache.default of genres. And here we use our context, the genres, the to list. Now, otherwise, we get genres for memory cache.default of genres. And note that this returns an object. So you need to cast it to an IEnumerable of genres. Of genre. Now, as I said before, you should avoid magic strings like this genres here. It's better to define a constant string, but I'm not going to go over that again because I'm assuming you're familiar with that. So this is data caching. But once again, from experience, I want to emphasize to use this technique if you really need to, and only after you have done performance profiling. Don't use this approach blindly to improve the performance of your application. Unfortunately, many tutorials tell you that you should use caching for frequently accessed data that don't change often. While on the surface this may sound like a good idea, in my opinion, this is poor advice for two reasons. One is that by blindly storing data in the cache, you will increase memory consumption of your application. Another reason is that it will lead to all kinds of unnecessary complexities, both at the architectural and code level, especially when you're working with Entity Framework. If in an action you're modifying data with Entity Framework and you want to reference some of the objects in the cache, you're going to run into all sorts of issues because those objects are not part of your DB context. So when you save changes, you're either going to get duplicate data in your database or exceptions thrown by Entity Framework. As a workaround, you have to attach those objects to your DB context, but once again, that itself can cause other issues. So to recap, use this approach after you have done your performance profiling, and also limit it to actions that are used for displaying data, not modifying it. Next, I'm going to talk about a common misconception about asynchronous operations. One of the misconceptions about async and await in .NET 4.5 is that they will increase the performance of your application. But that's not true at all. So let me quickly explain how async works and when and if you will benefit from it. In web applications, when we receive a request, runtime allocates a thread to handle that request. Now, when it comes to I/O-bound operations, like accessing a database or a file, or network-bound operations, like calling a remote service, there is always a delay. For example, in the case of accessing a database, this thread has to wait until the database executes the query and returns the result. Now, since we have limited amount of memory and threads available in a web server, if we have a lot of concurrent users, at some point, we may run out of threads because many of these threads are waiting for I/O-bound or network-bound operations to complete. In this case, we either need to add more hardware in terms of memory or more machines, or we can use async and await. This is something I've covered in my C# Advanced course, so I'm not going to go into details because I don't want to waste other people's time who are already familiar with this concept. Now, when we use async, our thread will no longer wait for the database to return the result. It will be released so it can serve other requests. So this does not improve the performance of our application because it does not reduce the average response time. We still have to wait for the database to return the result. But during that wait period, our threads can be better utilized to serve more concurrent users. And this means better scalability, not performance. But even when it comes to scalability, async and await do not always improve the scalability of your application. Look at this diagram. Imagine this is a pipe. We pour water from the top and it comes from the bottom. Now imagine on the top, we have a bunch of HTTP requests coming to our web server. So near the top, we've got IIS, and near the bottom, we've got our database server. When we use async and await, it's like we are opening up the top of this pipe a little bit, so we can pour more water or more requests. Now our pipe looks like a funnel, but look at the bottom. It's still the same size. So if you're using a single instance of SQL Server, that's going to be your bottleneck, no matter how many more requests you can serve in IIS, because all these requests will eventually have to wait for the database server to respond. On the other side, if you use a SQL cluster or a NoSQL database like Mongo or Raven, which is designed for scalability, or SQL Azure, that's a different story. The bottom of the pipe will also expand, and that's when you have true scalability. So async and await do not improve the performance of your application. They can only improve the scalability given that you're not using a single instance of SQL Server. So in terms of the application tier, we have looked at output and data caching strategies. Another simple optimization technique is using release builds. So in Visual Studio, we've got this drop-down list on the toolbar where you can select the build mode. By default, it's set to debug, so when you compile your application, the compiler adds additional data in the assemblies which are used for debugging. But when it comes to deployment, we don't need this stuff. So we should use the release build, which will produce slightly faster and smaller assemblies. We'll look at deployment later in the course. And the last optimization technique I'm going to talk about in the application tier is disabling the session. I've not covered the session in the course because it's something you should really avoid. If you don't know what session is, it's basically a piece of memory in the web server allocated to each user. So we can use that to store temporary data during the user session. Now, what's wrong with using session? Because the more users you have, the more memory of the web server your application is going to use. This kills the scalability of your application. The days we use session in web development are gone. These days, we are working on more cloud-based solutions, and it's more likely that the traffic to a web application increase exponentially. So, to make your web application scalable, you should make them stateless, which means a request comes in, gets processed, and we're done. We don't maintain state. We don't use session. Now, to disable session, in Solution Explorer, open up web.config, and in system.web, add session state and set the mode to off. Note that this value is case sensitive, so O should be capital. So this is how we disable session state, which improves the scalability and the performance of our applications. So here are the 4 strategies I've covered in this section that we can apply in the application tier to optimize performance. Output caching, data caching, using release builds, and disabling session. Out of this list, it's safe to implement the last 2 without performance profiling, because they're simple and don't add any additional complexity to your application. Next, we're going to look at optimizations in the client tier. Okay, we got to the optimizations for the client tier. The optimizations we apply in this tier are based on 2 simple principles. We have the client and the server. Since these machines are located in different geographical areas, we should reduce the number of requests from the client to the server and also the size of the response. So we can apply this principle in various areas. For example, when building APIs, we should aim to keep our DTOs lightweight. Now, if you're building a public API that many other applications will use, that's a different story. You may want to return a bit more data. But otherwise, if this API is internal and is used only by the front end of your application, avoid returning any unnecessary properties. Same principle can be applied to our JavaScript and CSS files. To reduce the number of HTTP requests, we combine them, and to reduce the response size, we compress the result. And that's where our bundles come into the picture. When we put our JavaScript and CSS files into these bundles, ASP.NET will combine and compress them at runtime. So just to refresh your memory, here in layout.cshtml, we have a reference to one of our bundles. And by the way, this is another optimization technique. We should put the scripts near the end of the body section, because sometimes it takes a bit of time to download these scripts, and to give the user a fast and smooth experience, we want to render all the markup first so the user can see something appearing on the page. If you put the scripts on the top, some of the browser's resources will be wasted to get these scripts before rendering the content. Now let's see a demo of bundling in action. So back in the browser, on the Movies page, I've got Chrome Developer Tools open, and I'm going to refresh. Now look at the Network tab. Here we can see all the requests sent from the client to the server. So totally we have 24 requests, and their total response size is about 80 kilobytes. We can filter this request. For example, let's take a look at JavaScript files. So totally we have 8 requests for JavaScript files. But hang on a sec, what happened to our bundle? All right, back in Visual Studio, in Solution Explorer, I'm going to open up web.config. Here under system.web, look, we have an element called compilation. Here we can configure the settings that ASP.NET Runtime will use to compile our application. And note that this is different from how we compile our application with Ctrl-Shift-B or by pressing Ctrl-F5. When we build or compile our application, C# compiler gets our C# code and compiles it into an assembly. So we get a DLL in the bin folder. But when we run the application, ASP.NET Runtime has its own compilation process. Bundling our JavaScript and CSS files happens at this stage, at runtime. Now here you can see debug is set to true. We can either set it to false or just remove the attribute, because its default value is false. Save. Back to the browser. I'm going to refresh. Okay, now we have only 2 requests for JavaScript files. We've got Modernizer, which is a different bundle. And here's our lib bundle. This parameter appended here as the query string is a hash that ASP.NET Runtime calculates based on the content of our JavaScript files. So if we change them, this hash also changes. And this prevents browsers from caching the request. Now let's have a look here. Look, there's no space in this code. So that's how minification works. ASP.NET Runtime gets rid of all the white spaces and also shortens the identifiers. So here we have N and T, which probably used to be called something else. Now back to our web.config. Technically, you should never touch this compilation element here. So let's revert it back. In Solution Explorer, look, we've got two files hanging off web.config. We've got web.debug.config and web.release.config. When we deploy our application in the release mode, this file will overwrite the settings in the parent web.config. Let's have a look. This file uses XSLT to transform the original XML. So we can see in system.web, for the compilation element, this transformation removes the debug attribute. All right, we're almost done with this section, but there's one more thing I'm going to show you here, which is not really an optimization technique. It's more of debugging technique. So as I was working with these bundles and observing the total number of requests and the total response size, I noticed unreliable results. If that happens on your machine, the reason is that your browser has cached some of the requests. So you may switch to the release mode and notice that the bundle size is actually larger than before. Now in Chrome Developer Tools, in the Networks app, we've got this checkbox here, Disable Cache. This is pretty useful as you're developing and debugging your applications. So I would suggest to keep it on at all times. All right, we're done with this section. Next, you're going to see the cheat sheets. And we're not going to have any exercises in this section because currently we don't have any performance problems that needs optimization. In the next section, we're going to build a new feature end-to-end. So I'm going to show you a systematic approach to build a feature or an entire application end-to-end. And that will be a recap of all the things you have learned so far, plus additional material. So get ready for it. It's going to be a very interesting section. So before we finish this section, I need to clarify something. Throughout this section, I mentioned premature optimization a few times. And at the same time, I gave you various techniques to improve the performance of your applications. So does this mean you should never apply any of these techniques until you have performance bottlenecks? No, that's not what I meant. What I meant was do not waste enormous amount of time optimizing non-critical parts of your application, especially if these optimizations are going to impact the maintenance of your code. Don't make your code complicated and hard to maintain because of some small efficiency you're going to get. Software engineering is not black or white. There are always trade-offs. You may put your application on the load and notice that some critical areas need optimization. In that case, you can justify that the extra complexity in the code is worth the performance gain, because this will eventually give value to the users. So do follow the best practices that I showed you, the ones that I put together in the cheat sheet, like the database schema, queries, disabling session, and so on. But don't spend too much time on small gains, especially in non-critical parts of your application. So I hope that clarifies my point of view. In the next section, we're going to put everything together and I will show you a systematic approach to build a feature end-to-end. So I will see you in the next section.